Function operations, we're going to talk about operations with functions, and I'm not going to spend a real long time going through the basic operations because I want to spend our main amount of time on composition. But what we'll do is we'll define some functions. Let's say f of x is 3x squared plus 6x minus 5. And then maybe I tell you that g of x is 2x to the 4th minus 5x plus 1. With function operations, what you're going to do is the functions will be defined initially, and then they'll say, okay, if that's true, tell me what is f of x plus g of x. So tell me, when you add functions together, what do you do? Combine like terms. That's all it is. Combine like terms. Now I'm going to put a little note on here, and I know you think that you know this, but when you start mixing all the operations, it's going to start to get a little fuzzy for you. When you combine like terms, what do you do?
Combine it. Put the highest first, like that.
When you add, but what, like if I told you, looking at these two, I know that 6x and 5x or negative 5x are like terms, right? I know that because they have the same what? The same degree, the same exponent there on their variable. And when you add those, what exactly do you add? Do you add the exponents? Do you add the coefficients? What do you, the coefficients. You only combine coefficients, okay? Leave the exponents alone.
So the whole numbers.
Correct. So looking here, if I did 3x squared plus 6x minus 5, and I'm going to put it in parentheses so you can see the difference in the functions here, plus 2x to the 4th minus 5x plus 1. Am I going too fast? Okay, I'll slow down a second. Always start with your biggest exponent, because good math form is to have it in standard form anyway and have your exponents descending, okay? So start with the biggest. What's the biggest exponent you see? 2x to the 4th. Is there another power of 4?
No.
No. How about the next one?
3x squared.
3x squared. I mark them out when I use them, especially when these jokers get big. Well, they're not like terms, so you can't combine them. This is a power of 4, this is a power of 2. Okay? Now, I don't have any, oh, actually, I got powers of 1. And this is the one we were just talking about. Okay, so 6x and negative 5x. So it's just x, right? A positive x.
Can you put 1x?
You can if you want to.
Minus 4.
-4, because that's my constants.
Okay, this is,
Dumb, easy?
Yeah.
Okay, good, good. All right, so what if we changed it then to subtraction?
It's the same thing.
So what if I take these same two, exactly. If I take these same two, and instead of addition, just so I don't have to redefine functions.
You do the plus, minus.
I'm froze.
Minus.
And this is kind of why I wanted you to put them in parentheses. So now if I have 3x squared plus 6x minus 5 minus 2x to the 4th minus 5x plus 1.
Same.
That's right. And whenever you do, you want to same this one, change the sign.
Change.
Exactly. That's what I was waiting on.
Oh, subtraction, same.
Yes, you want to change everything inside. Yeah. You want to change everything in the parentheses that follows the subtraction sign, because you're subtracting that entire function. Does that make sense? Mm-hmm. Okay. So now you can get your like terms together. Again, start with the biggest.
3x squared. No, never mind, sorry.
That's okay. What's your next one?
3x.
There you go.
I was looking at the last equation.
Now look at your x's.
11x.
What else?
Minus
-6. Yes or no? All right, so, no. We've established, go ahead.
I was gonna say, I ain't saw that negative in front of that one.
circle it.
Circle it. I thought I was country. All right, those are easy, yes? There's nothing wrong with being country.
I know. It's worse than everybody else. So
And then you can do up.
All right, let's change this one more time. Again, I'm keeping the same two functions defined, so you don't have to keep changing them in your notes. You can just keep referencing those same two. All right, what's left?
What are you talking about?
Multiplication. We've done division because we did polynomial long division, remember?
Oh, no, I know.
So we can do that. But what if I told you to find f of x times g of x? Ooh. Ooh is right. All right, before we start working through this, when you multiply two terms together that involve variables, okay, and coefficients, what do you do? Multiply what?
Oh,
No, but like if I said 2x to the 5th times 3x squared. Multiply the coefficients and add the exponents. You do, but I'm telling you, when you start doing everything together, everybody always starts getting mixed up. So it's good to have a little reference to remember, oh yeah.
Add everything together. Like, I thought we just learned this one.
All right. Now, yours are going to have some maybe fractions thrown in there too. Plus 6x minus 5 times 2x to the 4th minus 5x plus 1. What do you do?
Multiply them.
I put it in a box.
You start distributing. Tanner puts it in a box. I don't know what kind of box you put.
It's so much easier, Miss McGee. Can I show you?
What if you, but it'll work with any polynomial no matter how many terms it has?
yeah.
Can I show you?
No.
Yeah.
Yeah. Oh, you talking about ladders?
Yeah.
Ladder multiplication? Oh.
Miss McGee.
I know what that is.
No, don't show me right now because I don't want everybody to be confused right now. But
Okay, I'll show you later.
okay, show me later. All right, let's multiply. 3 times 2 is, hello, 6x to the,
No, to the 6. See, they need to be
6.
minus,
15
Got that.
x to the 3rd.
plus.
3x.
I'm done with that one. On to this one. 6x times 2x to the 4th.
12x to the 5th.
Yeah, I'm sorry.
We did this when we did long division. Didn't we do a section
Yeah, we
before?
did this. This is on the test.
6x times negative 5x. No. 6x times 1. It's not, Shamik.
Huh?
It's not. Negative 5 times 2x to the 4th.
Negative 10x to the 4th.
It's good review for your midterm anyway. Negative 5 times negative 5x.
5x.
Last one.
Negative 5.
Negative 5. Gather your like terms together. 6x to the 6th. If I'm going too fast for this, stop me. 12x to the 5th. Any powers of 4. Yes. Minus 10x to the 4th. 3s. What we got?
5x.
That's right.
This is so much harder than the box. It's so much more confusing.
Squareds. Minus 27. Plus 31. Minus 5. All right, function composition. Let's take that same f of x. Somebody give it to me because I'm going to rewrite it up here.
It is
You need me to go back?
3x squared.
Okay, hold on. Let me go back a second. All right, finish with the f of x for me. F of x equals
3x squared
Uh-huh.
plus 6x minus 5. And then
I don't need g of x right now. All right. Let's say, well, go ahead and give it to me. I'm going to write it up here.
g of x equals 2x minus 5x plus 1.
Okay. Let's say I'm going to also define an h of x. Let's just call that x plus 2. We'll make it easy. Let's say I asked you what f of negative 2 is. What would you do? Plug it in for x, right? 3 times negative 2 squared plus 6 times negative 2 minus 5. And we could finish working this to get 4 times 3 is 12, minus 12 minus 5, which is negative 5, right? What if I change that to, tell me what is f of p?
You're going to replace all the x's.
You're going to replace all the x's with p. What if I asked you to find f of
X times y.
2x?
Replace everything with 2x.
Replace all, I know this is sounding very redundant to you. Some of you are looking at me like, what are you doing? You would replace all the x's with 2x, right?
Yes.
So what if I asked you to find f of g of x?
You would put in f of g of x? That's going to be super long.
I would put g of x
Oh.
in for every x that I see here, right? The point is, and I'm not going to work that one out, but I am going to work out one with you in just a second. I meant to say f of h of x, but I didn't want to.
Oh, God.
Whatever is in this parentheses is what replaces your x.
You gonna be on walk off for 30 minutes.
No. Let's do f of h of x.
What?
Squared.
So that means I'm taking f, and everywhere f has an x, I'm replacing it with x plus 2, right? Okay. So I have, let me copy the problem first. 3, instead of x, it's now x plus 2 squared.
Squared plus 6x plus 2 minus 5.
Can I distribute? Can I distribute that squared?
Will you? Yeah.
What?
Squared.
No, you gotta give it.
Wait.
I got multiplied out. Remember, if there's a plus or minus inside, that tells you how many times to write it. If it's a multiply inside,
Yeah.
then you could
do it
distribute.
twice.
Do it twice, right?
Yeah, that's what I was thinking. Sorry.
All right, let's do it. X squared plus 2x plus 2x is plus 4x. I just skipped a step there.
What's he do?
I foiled it out or multiplied it out.
Wait, how did you manage to get 4x?
All right, watch. X plus 2. I'm out of room, so I'm trying not to.
It's not even on the screen anymore.
Sorry.
What?
Yeah, you're messed up.
X plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4. Right?
You add some x.
And then you add the 2 x's together to get the 4x.
Okay. I'm just like, what?
I'm just really confused.
Where are you confused? Oh, I forgot to hit record. I'm sorry.
Plus
Correct. So 3x squared plus 12x plus 12 plus 6x. 12 and negative 5 is 7. I'm out of room, so I'm going to have to write it right beside it here. The x's are 18x. We'll do another one start to finish. Where'd I get what? 12 and negative 5. Oh my goodness. Wait till we have to verify Monday.
Can you not? What does that mean? What does that mean?
Oh, hold your horses. I know y'all are excited.
You should just let me get out.
Maybe we can divide 3 by 2.
Alright.
And on your test, you have several that look like this, but then you also have some next Thursday.
Okay.
Let's do a new f and g. Let's say f of x is 2x minus 7, and g of x is x squared plus 4. First,
It's a lot easier.
F of x equals 2.
let's do f of g of x first.
So plug in the g's or the x's there.
Okay? So I like to rewrite it like this, because it helps me visually see what I'm plugging in for x. I like to replace the g of x there like that. So that then I know, well, I'm going to look at f, but everywhere I see an x, I'm replacing it with this. Okay? So it's 2, and it's not x anymore, it's... Oh, wait.
It's not hard, it's just long.
X squared plus 4 minus 7.
Minus 7. Oh, what's this?
So it's 2x squared plus 8 minus 7, which is
2x squared plus 1.
plus 1. Yeah,
That's all?
that's it.
It's all, it's gonna be that
Okay,
short all
let's
the
start
time.
No, not all the time.
Let's start our homework.
Which side is it?
Yeah.
You instead, you just plug
Hey,
in
you
the
know
right.
what?
Let's see how, yes, let's see how well you really understand
I
it.
just put my hand up.
You try this one.
So f of x. So it's going to be f of x squared.
No, I'm not multiplying it.
Don't have your mind.
But
F of x. Replace what's in the parentheses with what you know, like I did here.
F of x.
what?
What is f of x?
2x minus 7.
2x minus 7. But you already did that. And then you're going to do it twice.
I'm not. What'd you tell me about what's in parentheses? What's in parentheses is what you replace every x with, right? I'm just plugging it into itself.
Exactly.
So, but that's what we just. Oh, we didn't do that.
Yes. It's still 2x minus 7, but the x is replaced with 2x minus 7.
It's gonna be 4x. Minus 4.
Yes. Which is not squared, I'm sorry. 4x minus 21.
Okay. And then you write that down. Oops. Should they all be this easy?
How about g of f of 1?
Wait. You plug in.
Yeah, just plug in what? Finish what you're saying. 1 for what?
G.
I need to work for I need to find out what I need to plug into g. So to do that, I need to know what f of 1 is first. So I plug in 1 for f. So first thing I want to do is say, well, f of 1 equals,
What?
Oh.
what's in the parentheses is what you're plugging into g. But I don't know what f of 1 is, so I find it. Yeah. So if f of 1 is negative 5,
The x. X is
No, the
1.
1 is the F.
the 1 is the x in the f.
And then g.
Because at first I do this one and then I do this one. Inside out.
You look.
Just to clarify, verify, you're trying to find
Okay, so. Okay.
I'm listening.
Oh my god.
F of x is 2x minus 7. And what we're trying to do is g, parentheses f, parentheses 1, and then in the parentheses. That 1 is representing x. So you go back to the original f of x problem.
Okay.
2, parentheses 1, where the x was, minus 7. So you plug it in back into itself. So basically where x was in the original f of x problem is 1.
Does that make sense? No?
You gotta
One
do
of
that.
those time travel shows. You know, you just watch it and then all of a sudden there's like a paradox and you don't want
Wait,
to
Miss
say it.
Have you hit a paradox?
The
I'm
G.
hitting a moment
Huh?
of insanity.
Gotcha.
Paradox.
Finish. We can start our homework.
Wait.
Start our homework now. I want to get over this.
I don't want to have to do homework.
I have homecoming to go to, and then I also have a competition tomorrow.
Don't blurt out the answers when you get these. If you can get these 3 that I'm fixing to give you, then I will let you start your homework. I want you to find f of g of x.
Oh! Okay, that's not that bad.
I want you to find g of x. And then I want you to find g of f of 2.
G of f of g. I'll probably understand it then, honestly. What did you get out? Oh, that's how you do it.
G is 5x minus 2, so I just replaced that.
Minus 2 is the x.
What do I do with negative exponents? Put it in the bottom. My question to you is, what is the exponent hooked to?
Is it to the
5x minus 2, so that's the only thing moving. The 4 is standing alone. So it's going to stay up top. The 5x minus 2 is going to move down, and I really don't need to rewrite an exponent because a 1 is an understood exponent. So there's f of g of x. That's it.
Oh, okay, so
And
the negative 1 is just going to 5x minus 2, right?
G of
Correct.
G of x.
Oh, that's an exponent. That was my exponent.
G of x is 5x minus 2. So now I reference g, 5, not x, but 5x minus 2
So why is there 5?
minus 2.
Why is G 5? Why did you put 5?
5 times x. This is x now.
Oh.
So now I have 25x minus 10 minus 2, which is 25x minus 12. I need to do f of 2 on this one first because I need to know what f of 2 is so that I can plug it in the parentheses there. So I get 4 times 2 to the negative 1. Again, the 2 moves down, but not the 4, because the exponent's only hooked to the x and not the 4 as well. And 4 divided by 2 is
Then you go up like that in the
So
G,
you
right?
plug in 2 for F, but then what is G?
I'm not finished
So
yet.
then you plug in 5 times 2 minus 2,
Yes.
but then have
So now this, I know I can replace with 2 because I know that f of 2 is 2. So now the only question is, what is g of 2?
oh, already do that.
Yes.
I really don't get the point of learning.
We're going to use it to verify on Monday.
So the first part did have a meaning, it's just
Sam?